This is the video for section 3.3. In section 3.3, we're going to talk more about properties of logarithms. And the reason we talk about properties of logarithms so much is because we use so many properties in order to solve a logarithmic equation. So the first thing we're going to talk about, if you notice on your calculator, we've always talked about we have a common log, which is base 10, and a natural log, which is base e, and we have buttons for each of those on our calculator. But sometimes we may not have a problem that's has a base of 10 or a base of e. And we do not have a button on the calculator for any other base besides those two bases. Now, the TI-84, if you have the updated operating system, there is a way that you can enter in any base that you want, but we're going to say that we're not able to do that in our calculator. So when you have something other than base 10 or base of e, then we're going to use what we call the change of base formula in order to write those with the base that we need. Okay, so here is the information about the change of base formula. Let a, b, and x be positive real numbers. A cannot equal 1 and b cannot equal 1. Then log base a of x can be converted to a different base using any of the following formulas. So it does not matter which formula you use, you will get the same answer no matter what. Okay? So here is the formula if we want to have a base of a number b. Okay? Our problem is log base a of x. Well, it's log base b of x over log base b of a. More than likely, we will always convert ours to either base 10 or base e, because that's what we have in our calculator. Okay, so all that you have to do is if you have log base a of x and a is some number, then you write this as log base 10 of x divided by log base 10 of a. And remember, most of the time, we don't even write this 10. If it's just log, we automatically know that it is a base of 10. Okay? Or we could use natural logs. I can rewrite it as natural log of x over natural log of a. So here's what I'm talking about, and you'll need your calculator in order to do these. I want to evaluate log base 4 of 25. Well, on a normal calculator, I cannot enter this in because it's not a base of 10 and it's not a natural log with a base of e. So I'm stuck. I don't know how to do this. So let's write these first two problems using the base of 10 so I can use my log button on my calculator. Well, I would write this as log, I'm using this one right here, base 10, but I'm not even going to write that because it's just assumed if it's not written there, of x, and x is 25, divided by log of 4. Now when I put that in my calculator, let me turn it on, I would hit log 25, whoops, so okay, sorry, my phone rang. All right, so I'm going to put parenthesis log base 25, close my parenthesis, divided by parenthesis log 4. And I get 2.3219. Okay, so now let's do B. Log base 2 of 12, and I have to evaluate. Well, in order to evaluate that and put it in my calculator, I need to use my change of base formula, and let's use the base of 10. So I have log of 12 divided by log of 2, and when I put that in my calculator, okay, let's see if we get the same answer if I don't put the top in parentheses. I'm just going to say log 12, close your parenthesis, divided by log 2. And we get 3.585, and that's right. Okay, so I'm going to write my answer down, 3.585. Now, I wrote the exact same problems down for C and D just to show you that if I used a base of E, that we're going to get the same answer. So instead of using base 10, let's change these using a base of E. So that would be this equation. So I would just write down natural log of 25 divided by the natural log of 4. When we put that in our calculator, natural log 25, close your parenthesis, divided by natural log of 4, and we get the same thing, 2.3219. On this one, it would be natural log of 12 divided by natural log of 2. When we put that in our calculator, move this over, natural log of 12 divided by natural log of 2, and we get the same thing, 3.585. Okay? So when you have to evaluate something that has a different base, it is not a base of 10 or not a base of E, use the change of base formula to evaluate those. Very easy. Okay, so let's look at the next thing. All right, now we're going to talk more about properties of logarithms, and you guys, I'm sure, had this in Algebra 2. But if I have, rule number 1, log base A of u times v. Anytime I have a logarithm, and this holds true for natural logs or common logs, if I have two things being multiplied together, I can rewrite that as an addition problem. So this is the same thing as log base A of u plus log base A of v. A division problem can be rewritten as a subtraction problem. And anytime I have an exponent, I can rewrite that and bring the exponent out in front. Okay, so I'm going to show you what those look like. So example 2, let's look at A. Write each logarithm in terms of natural log of 2 and natural log of 3. So here's what they're saying. I need to write natural log of 6 only using these two numbers. Well, we know that 2 times 3 equals 6. So I could say this, the natural log of 2 times 3. Okay? Well, now I'm going to use properties of logarithms to rewrite this. This means natural log of 2 plus natural log of 3. Okay? Because multiplication can be rewritten as an addition problem. Okay? Now, 2 over 27. Okay? So first of all, so this is natural log of 2 over 27. That's what that is. All right? Well, I can only use the numbers 2 and 3 to write this. Well, my 2 is okay, so that's going to be natural log of 2. But how can I write 27 using only the numbers 2 and 3? Well, 27, do you see that 27 is 3 times 3, which is 9, 9 times 3, which is 27. 27 is 3 to the third. So I'm going to rewrite 27 as 3 to the third. So now I'm going to use the properties of logarithms to rewrite this. Well, I have natural log of 2. Remember, division problems can be rewritten as subtraction problems. So minus the natural log of 3 to the third. But then when we're using properties of logarithms to rewrite, this exponent can go in front of this logarithm. So I have natural log of 2 minus 3 natural log of 3. And that's how I would write that. Okay. Example 3, same thing. Use properties of logarithms to expand each expression. So this time, we're going backwards. All right, so they want me to, this is a multiplication problem. So multiplication problems can be rewritten as addition problems. So it's going to look like this. Log base 4 of 5. Now 5 is being multiplied times this, so I can say plus log base 4 of x to the third plus log base 4 of y. Now I have an exponent, so this exponent can be written in front of that log. So my final answer will look like this. Log base 4 of 5 plus, I'm going to bring this 3 down, 3 log base 4 of x plus log base 4 of y. And that is my answer. Okay. Let's do B. All right, we should know that anything underneath the square root is really to the 1/2 power. Okay, so really this is my problem. So this is a division problem. So I have natural log of 3x minus 5 to the 1/2. Division can be written as subtraction, so I have natural log of 7. I have an exponent, so that exponent can be rewritten in front. 1/2 natural log 3x minus 5 minus natural log 7. And that's my answer. Right. Now the last example, we're going the other direction. Use the properties of logarithms to write as a single logarithm, or the directions in the book might say condense each logarithmic expression. So that means when I write A, I need to write log base 10 one time. Okay, so I'm going to write log base 10 of x. Well, this is in front of a log, so that means it used to be an exponent. So that exponent has to go above my x. Then it says plus, but plus is rewritten as multiplication. I don't write my log again, I only write it one time. It's x plus 1, but this 3 is in front, so that used to be an exponent. So that is my answer, or we should know that anything to the 1/2 power is the square root. And then that is my answer. Okay. Let's do this one. Okay, I'm going to write my logarithm one time. So this, in this case, it's natural log. I have x plus 2, but then this 2 used to be an exponent, so that goes above. Minus means division. I don't write the natural log again, and it's just x. And then that's my final answer. Okay, so for your assignment, well, I'll tell you what your assignment is in class. Okay, but that's it for the notes on section 3.3. There's a couple of word problems that we will do. We're going to do all the word problems all as one section. So you shouldn't have to worry about any of those unless it's a human memory model problem like we've done before.